3.7. Solve systems of equations by graphing. So you need to know how to graph equations and to solve them. What is a system? A system just means more than one equation at a time, and we're trying to find the solution. And the solution is the point where the two lines intersect. So graphically, we'll be able to see that. So I listed the steps I'm going to be taking to solve this, or to solve this system. First, I'm going to identify the slope and the y-intercept in each of the equations. So this first equation right here, the slope is equal to -2. And remember, slope is rise over run, so that means it's going to be -2 over 1. So it's going to be a fraction even though it doesn't look like a fraction. And then the y-intercept for this first equation, there's nothing there, so that means my y-intercept, I'm going to say y-intercept like that, or my b, is equal to 0. So this is my first line right here. This is line A. So I'm going to call that line A and call this line B so we can know which one I'm talking about. Line B has a slope of +2. And again, as a fraction, that'll be 2 over 1. And its y-intercept, or b value, is 4. Okay, so once I have my things identified, I am going to graph these two lines on a coordinate plane. So since I don't have a coordinate plane, I'm going to draw one myself. So here we go. I'm going to draw it. It's probably best to use a straight edge, like a ruler or a side of a paper or something. But you want to make the lines as even as possible. So what I do, I go right in the halfway point between each of the blue lines, and then I kind of guess going this way, trying to keep them all about the same length between. So here, each of these will be 1. So I'm going to let you see me create it this time so you can see how I got it right there. So here's my x and y axes right here. So 2, 4, and 6. All right, so what do I start with? I want to plot the y-intercept first. So for line A, the y-intercept is 0. So here is my 0 point right there. And then I use the slope to get another point. So from there, my slope is -2, 1. So that means if it's negative, I'm going to go down in the, down. So 1, 2, and then 1 to the right since that's positive. So right there, 1 to the right. Okay. So there it is, and I can do it again if I like. 1, 2 down and 1 to the right there, and draw a straight line. So this is where the straight edge comes in. You want to make sure you get it as straight as possible and make sure they go through all the points. So here we go, right there. So this was my line A. Okay. Line B has a y-intercept of 4, so I'm going to go up here now, up to 4, and then use the slope for that one. The slope is +2 and +1, so that means I'm going to go up to 1, 2, and over 1 right there. And I can do it again if I like. Go up to 1, 2, and over 1 right there, and then draw a line through these 3 points. So make sure I have some space right there. There you go. So let's see. There you go. That's all right. So now we see, and this is line B, we see that it crosses right here. Right there where it crosses. And because I don't have a perfect graph, that's why now I'm going to check. So I think this is about, because since we're doing it by graphing, they want to give us numbers that work. So it looks like it's about -1, 2. So I'm going to check right here. This is at -1, 2. So I'm going to check to see, does it work? And what does it mean to check? It means I'm going to plug this in for my x, -1 for my x, and +2 for my y into both equations to see if it comes out true. So here is my check right here. Check. So I'm checking A. I have y equals -2x. So let's plug it in. It says y is 2 equals, so I want to check, does it work? And then I have -2, x is -1. And what do I get? -2 times -1 is a +2. So +2 equals +2. That checks out for A. What about for B? So if I do B, B is y equals 2x plus 4. Again, my y is 2 equals, and my x is -1. So we put the -1 in here. We're trying to check to see if it is true. So 2 times -1 is a -2. So we get -2 plus 4. -2 plus 4 is a +2. So here we end up with 2 equals 2. So our solution is -1, 2. This is where they intersect. So our solution to this system is the point -1, 2. Okay, in this second example, again, I have a system of equations because there's 2 equations. And we want to solve it graphically or by graphing. So we're trying to find out where do these 2 lines intersect or cross each other. So we will do the same steps that I did before. Identify my slope, identify my y-intercept, plot the y-intercept, use the slope to get the points for both lines, and then determine where do these 2 lines cross each other and check to see if that is that point actually works. So I grafted them. I grafted the 2, or grafted. I graphed both equations, and right here I see that if I keep going, they do not cross. So because of that, there is no solution. No solution. This is a situation where the system has no real solution because, again, we're trying to find out where do these 2 lines cross. Well, these 2 lines are parallel. Parallel lines. Parallel lines. Okay? So there we go. Okay, in this example, example 3, I have 2 equations, but this time my second equation, or my equation B, is not in the slope-intercept form. So I can identify the slope and y-intercept in A, which is the slope is 2 and the y-intercept is 1. But in B, it's not in slope-intercept form because the y is not by itself. It has that -3. So guess what? I have to put in the slope-intercept form. So if I put it into slope-intercept form, I need to add 3 so that I can cancel out the 3 there. And whatever I do to one side, I must do to the other side. So I do that. I end up with y on the left, 2x on the right, and then -3 plus 1 is a plus 3 is plus 1. So wait a second. Look at this. Line B equation is exactly the same as line A. So guess what? If I were to graph this, how many lines would I have on the graph? 1 line. So here we go. So since I end up with 1 line on here, that means both of these lines cross at all points. So what does that mean? We have infinite solutions, because they cross at every single point and the lines go on forever.